Hey, Algebra 2 students, this is Mrs. Tran-Bloom recording for section 1.2, Piecewise functions. The first four examples says, consider function j, graph to the right. So function j, students, is this right here, okay? So when you see function f, function h, function whatever variable we are giving the function, it's just a name for that particular graph or equation. Number one, what is the output when the input is 5? All right, so output is the y value. It's looking for what is the y value when x is 5. Now, this is how we write it in mathematics. This is x, and we're looking for y. So now go over to the j function, locate 5 on x. Now, sometimes you go up, sometimes you go down. Now, go in this particular case, we're going to go up and see where the y is, or what the y is when we go up. So when x is 5, y is 5. So students, the output is 5. So when x is 5, y is 5. In this case, it's also read j of 5 equals 5. Number two, what is j of 1? This is the x value, aka the input. So again, we're looking for the output. Similarly, go over to when x is 1. And again, in this particular case, we go up to the function. Well, this order pair is 1, 2. So students, when when x is 1, which is j of 1, your y value is 2. Okay. Number 3. What is j of negative 6? And again, this is your input, the x value. So we are going to count 6 units to the left. 1, 2, 3, 4, 5, 6. So here is negative 6 on x. And this particular case, we go downward. This is where negative 6, negative 1. So the output, the y value, students, is going to be negative 1. So this is read j of negative 6 equals negative 1, aka y is negative 1 when x is negative 6, aka when x is negative 6, y is negative 1. All right, so it says here, the reversed. Reverse means we're going to do the opposites, right? We now know the y value, right? This is the y value, the output. Well, what is x? Well, we already found it, but let's kind of look over it again. Well, if we know the y value is at negative 1, here's y value of negative 1, students. Okay, as you can see, it only intersects our function j at one time, and that one time happened to be when x is negative 6. Okay. Number 4, what is x? Oh, so this particular example, we are looking for the input. What is x if j of x is negative 2? So notice how we are writing the y value as j of x. So this is really saying, okay, well, y is negative 2. What is x? Okay, so let's go over and look at our function j. I'm going to go and erase a couple of these. So if you already marked your notes, leave it. Now, the reason I'm erasing is so we can see a little bit better. So when y is negative 2, here's negative 2 on y. As you can see, it's only intersecting our graph function j here one time, which is this spot. So we are now going to count it. Ready? 1, negative 2, negative 3, negative 4, negative 5. Perfect. Negative 6, negative 7, negative 8. All right. So your x value, what is x? X is going to be negative 8. And that's your answer, students, for example 4. Let's go on to this next paragraph. Notice how the graph above is not one straight line. There are multiple pieces. In this particular case, there are 3, okay? Piece number 1 is this segment. Piece number 2 is that segment. And piece number 3 is that right there. So I'm sorry, this is going to be a ray. A ray means it has one arrow. This is a segment. That means it started and ended, and this is a ray. Okay, so it has 2 ray So this is array, this is array, and this is a segment. So it has 2 rays and a segment. So this has 3 pieces. So there are multiple pieces, 3 actually, that can be represented by different equations. The following function is called a piecewise function because the function is defined by 2 or more different equations applied to different parts of the function's domain. So as you can see, these are different domains here, and it's made of for multiple parts is used to make one function. Okay. In order to evaluate a piecewise function, one must first determine which piece of the function to use based on which domain the given x value belongs to. So now my recommendation to you, because we're starting out piecewise here, it's our very first time doing piecewise, unless you guys remember it from Algebra 1, is to graph out the domain on a number line. So I'm going to start with, and notice how we have 3 pieces, so that's why I'm making my 3 number lines here. I'm gonna go 1, 2, 3. It doesn't have to be fancy, okay? All right, so here's -3, here's +1, here's 2, similarly 2, and all 3 pieces. It's best if you guys line them up the same way. Okay, and so the first restricted domain is when x is less than -3. Now less than -3, we are going to have an open circle and it's going to give us a segment. Okay, so less than means we're going to the left. So any x value that is less than -3, we are going to use that very first piece. Second, when x is in between -3 and +1, I'm sorry. Well, it's inclusive because there's an equal sign. So we are going to use a closed circle. This means it is going to be a segment. Now, any x value in between -3 and 1, we will use the second piece to calculate the output, the y value. Now, the third restriction on domain is when x is bigger than 1. So this is, again, it's an open circle because there's not an equal sign there. And it's going to be a ray going to the right side because it's bigger than 1. Now, any x value that's bigger than 1, we will use the third part here to calculate the output. Okay? So let's calculate examples 5 to 10 using that particular piecewise function called f. Example 5 starts with find f of -5. All right, guys. So -5 is your x value. We are looking for the y value, which is your output. So we know x is -5. Your output is what we're trying to find. So since we know what x is, I'm going to erase all these markings over here. X is -5. So out of all of the 3 restrictions, we have when x is less than -3, when x is in between -3 and 1 inclusive, when x is bigger than 1. Well, since x is -5, we know that we have to go to this first ray, which tells me that we have to use the very first piece to find our y value. So f of -5 is going to be using the -x. Well, negative is already there, so we are just going to plug in whatever x is. Well, x is -5, students, so negative times a negative, our final answer is 5. So f of -5 is +5. Okay. Now, number 6, find f of 1, and again, 1 is the x value. Out of the 3 restrictions, can you please tell me first, second, or third? Which one should we use? I hope you said second, because the second, it's including 1. It's a closed circle. So we are going to use the second piece here to calculate the y value. So f of 1 is going to be 3 times x, and x happens to be 1, and plus 9. 3 times 1 is 3 plus 9 is going to be 12. So f of 1 is 12. F of negative 3, okay, again, out of the 3 domain restriction, students, first, second, or third, which should we use? I hope you said second again, because on the second one, the negative 3 is inclusive, right? It's a closed circle. Let me get a different color. So anytime it's a closed circle, if there's an equal sign, that's including that value. So we are going to use the second equation again to find the y value, for example, 7. So f of negative 3 equals 3 times the x value plus 9. The x value happened to be negative 3. Plug it in. So that's going to give us negative 9. Whoops, you can't see the negative. So negative 9 plus 9, and our y value is 0. Yes, it's okay to have 0 because that's just an ordered pair. Think of it as a negative 3 comma 0, okay, where the point is going to be. Number 8, f of 3, and again, the 3 is now going to be the x value. We are going to use the third equation, okay, because it's bigger than 1. So f of 3 is, well, the third equation, students, only has 10. It does not have any x in that third equation right here. So whatever the x value is, y is always going to be 10, and that's all that is. Number 9, find f of 0. As you can see, 0 is in between negative 3 and 1. So we are going to use the second equation. So f of 0 equals 3 times whatever the x value we are given. In this case, x value is 0. We plug it in. 3 times 0 is 0 plus 9. So our output is just simply 9. Find f of a negative 1/3. Again, find out of the 3 domain restrictions, which is the correct one to use. Well, negative 1/3, students, is in between negative 3 and positive 1. So we're back to using the second piece, which is going to be, let me write this down again. So f of negative 1/3 equals 3 times whatever x value we are provided. In this case, x value is a negative 1/3. So we are going to be, oops, I meant to say x. So we're going to plug in negative 1/3. Well, 3 times negative 1/3, students, is going to be negative 1 plus 9. So this will give us an answer of 8. Okay, students, example 11 to 16. The function g of x and its graph are shown below. Use them to find the following. So for this particular set of examples, we are provided with an equation as well as a graphical representation of that same equation, okay? Now, sometimes it's easier to find the answer from a graphical point of view, and sometimes it's easier just to plug it in from the equation. Well, as you know already, because we're just starting out with Piecewise, it's easiest to go through and look over the domain restriction. If you need to, make a number line and start with 0. Okay, all of them should be the same exact number line. So 1 and 2, so that's negative 2, and all of them should have the same. Okay, here we go. And then we want 1, 2, 3 to the right, 1, 2, 3, 1, 2, 3. Okay, nothing special here, just a number line. So the first one, this is going to be x is less than negative 2. Less than means open circle because it's not an equal sign. And so we are going to go to the left and it's less than. And so that's going to give us array. Second, domain restriction has an equal sign on those. So that will give us a closed circle in between negative 2 and positive 3. And that's going to give us a segment. Remember, a segment is when it starts and it ends. And the third domain restriction does not have an equal sign, so it will have an open circle and it's bigger than 3, so that's going to be array going to the right. This will help us pick the correct, oops, why am I crossing those out? Pick the correct, erase, equation pieces here to answer examples 11 to 16. Ready? Example 11, find g of negative 7. Well, -7, students, is definitely less than -2 since it's all the way over here, right? So the first equation piece, oops, G, not F, G of -7 is, well, this particular case is a constant, is -4. So we can also check that with the graphical representation. Here's -5, -6, -7. Here's -7, students. Go all the way down, and this is -4. So -7, -4 is the point that we can plot on our graph, and that checks with the equation. Number 12, G of 0. Well, this is again the x value, and 0 is in between -2 and 3. So therefore, we will be using -x squared plus 5. Now, whenever you have a negative in front of a variable, be very, very cautious. It's a negative variable square plus 5. So we want to plug in whatever x is given right there. And this is your x value, so we can plug in 0 squared. Well, 0 squared is 0 times -1 in the front is still 0, and 0 plus 5, your output is going to be 5. Now let's check it really quickly on the graphical representation on the right side. Well, x is 0, 0 is right here. I can't go down because there's nothing down here for me to meet, right? We have to meet by going up. So when I go up, the y value of this particular curve is going to be 5, and that checks. Find G of 3. Well, students, we have 3 domain restrictions here. I would like for you to answer this question. Should we use the first, second, or third domain restriction to answer number 13? I hope you said the second, because the second has the 3 included. So we are going to be using -x squared plus 5 to answer. G of 3 is, and again, -x squared plus 5. Our x in this particular case happens to be 3, so we have to do that first. So 3 squared, students, is going to be 9. 9 times a -1 in the front is now -9. -9 plus 5, our output is going to be -4. Box that up. Let's go over to the right and check it really quickly. I want you to find 1, 1, 2, and 3. Here's when x equals to 3. Now we're going to go down because there's nothing above. Ah, look at that, right? So when x is 3, we do meet. See this right here? The y value is -4. So that dot can be labeled as positive 3, comma -4. And that checks with our algebraic equation. G of -2. All right, so let's, out of, again, the 3 domain restriction, students, first, second, or third, should we use to answer example 14? And again, I hope you said second, because second, it's inclusive, right? Inclusive means it includes that value. So we are again going to use the -x squared plus 5. And a negative, just like what it said, x squared plus 5. Our x happened to be -2. Plug it in. Do that first before you multiply the -1 in the front. So -2 squared, based on PEMDAS, we have to do that first. So that's going to give us a +4. +4 times that negative in the front is now -4, and plus 5 equals 1. And so our output is 1. Now let's go over and check it on the graphical representation. I'm going to erase this so that way I have more room. So when x is -2, -1, -2. Okay, so this one's a bit tricky on the graphical representation. Can you guys see that we can technically go up or down here? But there's a dilemma. All right, when we go down, even though we are hitting this open circle here, an open circle in mathematics does not include an answer, okay? So we cannot use the -4 for our answer. So we can go up. Well, going up is better because that's a closed dot, and a closed dot in mathematics means it's inclusive. I mean, it does include an answer. So that value of y is 1, and that checks what we have here algebraically. Just 2 more here for this particular set of examples. Find x. So this is now the reverse, okay? Find x, meaning that we don't know an input, but we do have an input of 9. An output of 9. So when an algebra when using an equation is more difficult, then go to the graphical representation first, all right? So I'm going to go where y is 9. So this is 5, 6, 7, 8, 9. So here's 9, and I want to make a number line, and anytime this line, not number line, just this line is y equals to 9, this line touches a graph, that should be your x value. Well, let's see. This is 5, 6, 7, 8, 9. I know that number 10 is misleading, and this is 10, okay? So 9 go up, nope, not 9. 10 go up, not quite 10. So if I were to do this for homework, I'm going to guess 9.5. Okay, so I'm going to get a different color pen. And 9.5 is our answer. Now, well, let's go and check it with the equation since we are given both here. So we can go and check, well, x is 9.5. That was our answer from the graphical. 9.5 is bigger than 3, so I'm going to use this equation here to check. Okay, students? So check. When x is 9.5, I'm going to go, okay, I'm sorry, I keep saying f, but it's really g here. G of 9.5 equals 2 times x, which is blank, minus 10. Well, x is 9.5, so we're going to plug in 9.5. Just see if we come out to be 9 as our final answer. Well, 2 times 9.5, students, is going to be 19. 19 minus 10, so that will definitely give us 9, and that matches what we were given for the y value. And so our guess was right. 16, find x. Again, this is a similar kind of question. So x is unknown, but g of x is 1. Now, g of x is the same thing as y, okay? So y is 1. So let's go over and look at our graphical representation to find the answer. Sometimes it's easier to go over and use a graph. All right, here, when y is 1, whoa, this is trippy, students. Okay, when y is 1, as you can see, I am touching the graph at 1 location, 2, and 3. Whoa. Now remember, this is a closed circle, so it does include that value as well. So that is a -2. This is a 2. That's in between 5 and 6, so we're going to say 5.5. So students, this 16 has 3 answers. -2, 2, and 5.5. And yes, it can have multiple solutions, okay? All right, students, example 17, last one of this section. Which of the following points are solutions to the function? Now, solution meaning that when you plug in the x value and the y value comes out to be the same, these are all the y values, then it is a solution of our function f of x is equal to a piecewise -3 when x is less than -5. Okay, so now you don't have to make these number line, y'all, but if this helps you navigate 1, 2, 3, 4, 5. Okay, if this helps you kind of pinpoint which piece to use, then make it. But if you already know how to do this, then you don't have to make this. Okay, so this is just for me to kind of one way to guide you how to use piecewise. Okay, so the first piece, x is less than -5. So -5 is here. Less than meaning that it's not including -5, and there's going to be a segment going to the left. Second piece is going to be -5 including, and then +2 not including. So inclusive means close, and not inclusive means open. So this is going to be a segment in between -5 and 0. The third piece is going to be bigger than or equal to 2, so that's going to be close, and is a segment going to the right. All right, so let's go and do A. F of -7, y'all. Well, -7 is going to be less than -5, so it will always going to be -3. Well, this -3 and that -3 is exactly the same, so yes, this first order pair is a solution of our function f. Second, 7, 13. So f of 7 is the x. If we get 13, then it's yes. If we don't get 13, then it's a no. So 7 is definitely bigger than 2, so we are going to be using the third piece here. Something plus 6, well, this is your x, so that gets plugged in there. So that's 13. It matches, right? So this is another yes. Let's go to C. F of -5 equals, and again, if we get an answer of -3, then it's a yes. If you don't, then it's a no. So -5, y'all, is this one right here, okay? Because the second piece has inclusive. So we are going to use 4 times x. So 4 times something minus 1. Well, our x value is -5, plug that in. 4 times -5 is going to be -20 minus 1. This is a -21. Well, it's definitely not -3, so no. Okay, so -5 comma -3 is not a point on our function. F of 0 equals, well, 0 is definitely in between -5 and 2. So again, we are going to use 4x minus 1. So 4 times blank minus 1, well, x is 0, plug that in. 4 times 0 is 0. So 0 minus 1 is going to be -1. Well, that's not the same, okay? So this is another no. That point close, but not exactly. All right, last one. 2 comma 8. F of 2. Now this one's tricky, y'all. 2 is not here because that does not have an equal sign. So we would definitely need to go to the third piece here. So it's going to be x plus 6, okay? So blank plus 6. Well, this is your x. So that's going to be 2 plus 6. That's 8. Whoa, it matches. So this last one is a yes. And that's it, students.